Good afternoon, everyone. Today, our goal is to know some of the function inside the Detector, and it's about object detection. So let's take a look at the Jupyter Notebook. Jupyter Notebook, first you open your terminal, and then try to enter your Detector repository. Go to tutorial part, then go to Python. There, you can find that folder named 1 tutorial object detector.ipynb, and then try to run that code. First, as we did in the assignment 1 before that, in the Jupyter Notebook, we know that we got some computational library like NumPy and SciPy. Just try to run this line first and to import some library so you can compute your code in the next line. And then this part, as you can see, we got our Detector logo, right? As you can see here, we use that. This is the Kenny detection. So this Kenny detection, as we already discussed it before, that the Kenny detection will change your image to some image with only white and black value, but it only shows you the edge of the image. Then it will only show you the shape of the image with some black and white. Try to run it. I guess all of you already tried this. Do you mind if I ask you some question? Probably like, what if you change this value to probably like 50? What will happen? Can anybody guess? I'll point someone to help me to answer. Probably Pound, maybe. What do you think?
If we say to 50, that it will expand the range of detection, but in this case the color is not that different. It also shows the similar detection result.
Yeah, right. Close enough. So it will show you. So let's try to run. Try to change the value, and probably you might know that it will have some like small distortion, but not too much. And you can see that it's the same as Professor Wang mentioned before. It's like the Kenny detection. First, the image is filtered with 5 by 5 Gaussian filter, and then it will goes to like finding some gradient. Then you will try to make your try to set your threshold from minimum to maximum, and by the time you're setting that, you will try after you try to run your code or try to make some value inside the minimum threshold or maximum threshold, you will find that, oh, this is how does the Kenny detection do. So if you're not setting in the good way, or you didn't find matching values for the threshold, it will show you some noise. Not only just the edges, but it will also show you some noise. And also, as we can see in the assignment 1 before, we got some in the edges part. cv2.canny img 50 minimum threshold and maximum threshold, and the last part is like aperture. So it's like the kernel. So the kernel actually in the library is default by 3. So you should put like the aperture size is 3 here. So if you don't put it, it will set by default is 3. So here is the point, is here. Yeah. So the next part is mostly it's like the most, not the most, one of the most important part in the Detector project or in your robotic vision project. So it will be detect your face detector. As you can see in your default Jupyter notebook, you will see the detector will detect about Professor Wang's face. So just try to run the code first. What you can see there. Run the code, Shift Enter. So actually in this part, you can also download some image, or maybe using your own image, your own picture. So it will be detected by this function. For example, like what I'm doing right now is I'm trying to changing the source of the image. As you can see here, in the one strip tutorial /caps1, this is my own image. If you load some other image, it will be like your rename one, right? So in this part, as you can see, probably what we use in the face detector is we call it hard cascade. Actually, what is hard cascade is, it's like this one. This one is like some function to detect the human image or image with face. So definitely you have to load some like, for example, like this file. In the hard cascade underscore frontal face underscore default, you have to load this like this is the library. So you can run your code, mainly the function in the CV, the open CV is this one. So detect the image is this function. So let's try to run, what if we change the scale factor? If I change it, for example, like 5, do you have any guess about what if we change it to 5? Let's continue to this part, to face detector. So what do you think about the scale factor? For example, this is my code, right? So I changed my image here. I use the Cleveland Cavaliers player, it's basketball player. So it will detect 3 faces here. And what would it be if I change the scale factor, not like the default one, like 5?
It can find more range, more bigger or smaller faces.
Yeah, actually what Michael just said is particularly true, because like in this scale factor, you can see that the original image, for example, if it's like 5 by 5, for example 5 by 5, and you change the scale factor like 2, for example like 5 here. I try to run the code, right? 5. What would happen here? It found no face. It will be no face. Why it happens? But because it's the original face is, for example, is 5 by 5, And then you try to you try to put some value in the scale factor. For example, you put like 5. And it will, the default image, it will be read by the function, but by scaling it 5 times bigger. So the range of the scale factor, it will be like, for example like this. You can see it here. So the bigger you try to increase the scale factor, it will get your image smaller, and it would probably the function will not recognize your image, even though that will be some faces are there. So for example, it's like the scale factor is just 3. So the scale factor is rescaled 3 times, right? So the function will have some way to recognize your image. Right? That is the scale factor does. So let you take a look at the other function. What will happen with the other function, like minimum neighbors and minimum size? What it would be done by this variable. By the time we also try to understand the face detector. So in this part, after you try to recognize your image, so it's basically the face detector, after you use the hard cascade, it also do some training, or this library, this function, do some like training to recognize your image. So this code is doing that way. So also you have to notice this part. It's like your face it has to be very in a certain distance. If you don't have questions, so let's try to take a look. After the function recognize the image, you can see here in the cv2.rectangle, it will try to mark your image, which is your image already detected, your face already detected, and it will mark your image. So basically this is how you load your image again. And then this value is the RGB value. So you know that like RGB is like 0 to 255, and just try to give your number and try to run it. And this RGB, so I put 255 here, and it will show you the box that will mark your detected image is green here. So, and try to change this variable. It will also show you how thick your recognized box is. Also, the scale factor. I forgot to tell you something about the scale factor. If you change the scale factor, it will also try to compute your detection, how fast it will be. So it will be like this. For example, you can see in the bottom of the box, bottom of the line code, there will be like CPU times user is how many seconds. So you try to change, like for example like 2, and we'll see that though the image are not detected, the CPU times is very important for the face detection, because like if you are applying this kind of face detection in a car or in some camera, you have to take a look at how fast the computational recognize your image. Otherwise, it will have some fatal incident happen. Probably like your image is not recognized or your face is not recognized, and then your autonomous vehicle or self-driving car cannot recognize there are people in front of them, and the latency of the recognition will affect the controller also. It will has a very big impact of it. So try to run this code, and then let's continue. In this part is we use this is a simple blob detector. So simple blob detector is actually how do you recognize some shape or some, for example, you have shape of, I mean like curved shapes. And then this image has the point, right? It has the value of the intensity value is from 2 until 255. Then try to run this code, and you can see what it would happen here. What would happen here? For example, you try to run the code, and you can see that there's a blue mark in every dot, right? That is the simple blob detectors. So it actually detects the circle. So the circle is they have their own size and they have the numbers. And this function, it shows you to detect this one. Oh, let's try to change the number. This part, what do you think about this part? The circle pattern dims tuple 7 by 3. What do you think? What is the circle pattern dims tuple equal tuple 7 by 3? This part.
Oh, because there is 7 by 3. The picture down there is 7 by 3. Yeah, and because this detect is using that use Lec21 points, and it see the distance and see the size, and it will load the 7 by 3 points, and it get this circle pattern.
Yeah, that's right. So this is, as you can see, the default pattern is given is circle pattern 7 by 3, and you try to recognize this 21 points of circle and which shape 7 by 3. So you can also edit the tuple, the dimension. And I want to ask something. What it would happen if you change the tuple? For example, you change it 7 by 5. From 7 by 3, change it to 5 by 3. What it will show you?
I think it will be the middle.
Okay.
Middle 5 by 3.
Middle 5 by 3. So let's try to run the code, shall we? As we can see here, what is Jack saying is correct. If you change 5 to 5 by 3, actually it will shift it. So the detection will be in the middle. And do you guys also see the line that try to make some pattern within the blob, within the circle points? That is what is simple blob detector. So simple blob detector actually detects shapes of some curvy shapes. For example, these shapes. And then these shapes, it will show you how many points are detected and how many points are has the circle pattern. So, And though it has some range between the circle patterns, you can change the variable here also. These two variables in params mean area and params mean the distance between blobs. You can also change it and see what would happen there.
Input the tuple to 8 and 3 and put an
8 and 3.
8 and 3.
Let's take a look. What would happen if 8 and 3? Yeah, right. As you can see here, because your image is your recognized image is actually the blob is 7 by 3. So if you put some much more than that, then it will be like shifted or not detect the blob.
And we also try 8 and 2, and it can detect some circle in the image, but it will also find
8 and 2.
I don't know why it find the leftmost things and it recognize it as a circle.
Circle. Yeah.
So it defaulted to circle. Good job.
Okay. Do you want to? Are you asking? Oh, you're asking about this, right? Well, how this could happen?
Yeah, I explain my question. First, if we try 7, 2, and you will find the
7 by 2.
2.
These top two.
In the image,
Yeah, right.
This time I try 8 times 2.
8 times
But
3.
it find the 7 times 2 circles in the image, but it also find another 2 circles at the leftmost.
At the leftmost of the black,
white paper.
yeah, the white paper.
And I want to know why this happens, but if this result is happening.
How does this result is happen? Yeah. In my opinion, there will be like some false detection. False detection. Probably if like there's some other things, shape looks like the circle pattern. So it doesn't have to be a circle pattern, but also looks like some circle patterns. It would also, you consider as this function will be like soap. I mean, there's some other things or other objects that could be detected as the blob. So it also makes some connection to the other blob. So this function actually, after you detect some blobs in a certain area, it will have some connection. So it will make some lines between the blobs, or from one to another blobs there will be a line. So that could be happen. Probably professor could explain in some cases how does it also could happen in the blob detectors. It's like the detection is considered as false detection. How does this could happen?
Well, according to the minimum area and minimum distance between blocks, right? So
This one.
just mentioned 8 by 2, and then there might be some other 2 blocks detected on the left-hand side. So you will try to link all the blocks. Okay. But I guess I think this well, this is like just some trick to maybe just to try to fail the algorithm somehow.
And the next part, as you can see, you can also load your own image, the circle pattern with the different direction. So it will be like this. These two, you can also load it, or you have some your own blob shapes that you can figure out in this function. So next, let's take a look at this part. So this part actually will try to, and in the Ducky detector, this part will show you how does the duckies will be detected by the Ducky bot. So you can see that how does the camera will recognize this stuff, for example, this mouse as a mouse. So in that time, you have your own initialized variable. For example, like this duck it has the range of the value is in the front. As you can see in your computer, also in the front. From that color range, you can consider that this color could be considered as the ducky. And then in this part, we try to shift the RGB value to the SSV and try to run the image, which you can see that it will be showing only like the white part of the duckies, or the detected duckies will be shifted to the SSV value and it will show as white duckies. Next part is, this part is like filtered contour. So as we know that some value in some image, they don't really like detect it as what is it, like initialized as mouse, initialized as mouse, but camera can do a lot of things, for example, like recognizing the color value. So, and at this part you can see that this is try to get the contour of the duckies, try to get some contour of the duckies. And let's do some detection of the duckies in the next part. So after you run this code, the filter contour is actually filtering the contour of the duckies. In this part, just try to run the code, and you will get the duckies are being detected. So basically it's the same as face detector, but there's some variable you have to initialize first in a filtered contour. So it will detect the duckies. The separation will be in this function. So the filtered contour, as you already try to try to recognize the shape, and it would have like some value there. There will be like sorry. There will be like some value like in that X, Y, W, and H, and it will make the recognition of the contour of the duckies. So first, you have like the shape. For example, this mouse. This mouse has the shape like this, some curvy and some flat, and those lines, even though the lines are the same, has the same color, it's red, but it's also plotting some point of the shape, so it will differentiate between the line and the duckies. Is that answering the question?
I guess so.
Okay, so it will be like that. Basically, it will be like that. So you can also take a look at the rest of the code, and you can try to run it. For example, like the MSER or convexal detection. Particularly, it will try to separate or parsing the part of the image. For example, like you have one area, and then they will have some desk, some CPU with some part of different part, and then the convexal or the MSER will try to parse and try to differentiate each area. Yeah, so you can try to take a look at the rest, and probably we can continue to the 1, 2, 3 stop tutorial. So actually, for example, in the DocuPod part, we can see that we are doing the self-driving car, right? So how does the self-driving car goes if there anyone like person or face are detected? Will it goes? Will it be like keep driving, or it will be stopped? So in this part, I want to show you some relative project related to the. So do you guys already try to run the camera node or joystick node?
Yes.
So who already succeed to run camera node and joystick node? Most of us already try to know what's happened in the joystick node and camera node. So probably I assume you also know about ROS, something about ROS, like node and topics, like publishing and subscribing. Do you know about these things, guys? Please let me know that you don't know about like node or topic or publishing something or subscribing something. At this point, just let's take a look only for the related project to the DocuPod. So for example, if you're running the code, you should have some experience with this one before, right? Like source environment, you try to activating the ROS, and then you try to set your ROS master to your name, to your host name you already set before. And then we try to, I'm sorry. Before that, I forgot to tell you, you have to make some SSH connection to your client, to your DocuPod. You already goes to your DocuPod, and then I'm going to show you some like so basically this program will detect some image. Let's say if you are driving, and then what it will do if you detect some obstacle or some face. Will it stop or not? So let's just wait for a while. In this case, I use some example. I use a professor's face, for example. So it shows you that it doesn't detect any face. What would happen if you detect some face? So when you find the image, or when you find the face, you cannot control your joystick. So it will be automatically stopped. So that's how does maybe some related project to the DocuPod. So right now we are doing this. We are going to do this part. So I hope you guys are pretty familiar with this one. So as you can see, it detects the image, right? Detects the face. Then you cannot shift it. If you and then, for example, if the person is already gone, and the person is gone, it won't detect the face. Then it will go. Then it can go right. So it will be like that. The related project.